Hello folks, this is Jack with part 3 of the BCD 7-segment decoder and time multiplexing presentation. I'm just going to start back where I kind of finished off. So this is a slide that I finished off on. So we've got a microcontroller. 4 bits of the microcontroller and a chosen port B randomly are connected to the 4 inputs of the BCD decoder driver integrated circuit. Now this decoder driver integrated circuit has a permanently low enable and we'll permanently enable the IC by taking that control line to ground. The device also has active low outputs, which means that you've got inverted outputs. On the output of the decoder driver, you can just imagine there are some NOT gates there which inverts the output. So it's the opposite to what you would kind of think it should be. Now we've also got 4 7-segment displays. In more detail, we've got 4 common anode 7-segment displays, and because a common anode, connecting these to the outputs of the decoder driver will make it work as if it was not inverted outputs. And I kind of explained this before in the previous slide. It's simply because common anode connection allows us to actually turn on a segment by giving it a 0 logic level at the input, and that's exactly what we've got on the decoder driver outputs. We've got inverted outputs, and the common anode 7-segment display works correctly with inverted outputs. Now the outputs of the decoder driver A, B, C, D, E, F, G are connected to each one of the 7-segment displays as follows. Now unfortunately we just have not got enough current to illuminate all the 7-segment displays, all 4 7-segment displays, because there's just not enough current there, and to try to illuminate all of them would mean that even one of them won't appear to be on, because there's just not enough current to illuminate the segments. Now what we can utilize here is we can utilize the common anode feature of the 7-segment displays and treat that as a chip enable. And we do that by using 2 to 4 decoder and 2 more pins of the PIC microcontroller. We've got bit 4 and bit 5 of port B, again chosen randomly, and outputs are connected. Notice the outputs of the decoder aren't active low, they are normal outputs. So 0, 0 will make Q0 high, and that high will be connected to the common anode of that segment, so a 0 at the input will result in a segment illuminating. Now the idea behind this circuit is to enable one of the 7-segment displays at any time. So enable one segment, send a value to the BCD decoder driver IC, and then allow that to be displayed on that segment, then disable that segment, enable the segment next to it, then send a new value to the decoder driver, so a new value is displayed, another value is displayed on the second segment, and keep repeating that all the way through. So what we in fact are doing are enabling a segment, sending a value, then disabling that, enabling the next one, sending a value, disabling that, enabling the next one, send a value, disabling that, enabling the next one, sending a value. This is the kind of multiplexing that we're doing. We're only enabling one at any time. But if we do this fast enough, in terms of our eyes can't pick up the fact that it's going off or on, and it just appears to be on continuously. So this is what we do. So for example, PB4, PB5, if there's 0, 0, then you've got Q0 at 1. That would enable that common anode of that segment, and I've just indicated that with a green line. And then we can send a value out there, 0, 0, 0, 0. That will be 0. Then disable that one, enable the next one. Enable that one, send a value, 1. Disable that one, enable the next one. Send a value, and that'll be that value there. Disable that one, enable the next one. Send a value, and that'll be that one there. So that's the way we're going to do it, but we're going to do it really fast, so that due to our eyes being a bit slow and not picking up the fact that it's going off and on, all 4 segments are going to appear to be on simultaneously. Now, why on earth am I doing this? Well, I'm doing this because this very circuit is used on the TIC-PIC that you're already familiar with. 2, it kind of brings together all the things that we've been, not all the things, but some of the things that we've been using: decoders, drivers, and multiplexing. This is time multiplexing. We haven't actually got a physical multiplexer here. We're just kind of doing it by kind of refreshing every segment at a certain rate. It's only one segment on at any one time. Now, on the actual TIC-PIC, I think even the multiplexing is purely done, time multiplexing is purely done in software, so there's no decoder there. It's just purely done in software in C, as you remember doing, no doubt. So that's the plan. Now, had we not used this kind of time multiplexing, we would actually need 4 separate decoders, and those will feed into each one of the an individual 7-segment display. And also, if we didn't have a decoder, we'd have to use 4 more pins there to actually control each segment of the 7-segment display. So doing this makes it more efficient in terms of we're reducing the pin count that we need, or the port pins, to a bare minimum. 6 port pins are controlling everything on this circuit here. So this is it. So if we refresh, or if we turn on and off each segment for 5 milliseconds, well, that time is actually enough, or it's fast enough for our eyes not to pick up the fact that it's going on and off. So there, and that's it. So it appears to be 0, 1, 2, 3. As far as the eyes are concerned, all 4 segments are on simultaneously. Okay, folks, I think this is all I really wanted to cover, and the PowerPoint slides and the videos are on Moodle. The videos are also on YouTube as well. So any comments are most welcome, and any kind of questions arising to anything that I've covered so far are also quite welcome as well. So thank you very much for listening, and I'll see you soon. Bye bye.